Alright, this video is on lesson 6.4, day 1, properties of logarithmic functions. Our objective is to simplify and evaluate expressions involving logarithms. So if you did not get it today in class, or you missed today, you should be good to go after this exciting, entertaining, and energetic video by Mr. Allen. Alright, an important fact about logs, a real quick one. So anytime you see something like this, where it's log base 2 of 2, or log base 5 of 5, or log base 12 of 12, or in this case log base 10 of 10, essentially what happens is it's gone and it becomes 1. So if it's an addition type problem, make sure you have that 1 plus whatever it is in there. But if it's multiplication, you can basically just take it away. So all these become 1. Alright, our two properties would be product property and the quotient property. So for product property, we're thinking addition. So when you have something like this guy here and it's m times n, so you have log base b of m times n, you can expand it into two different logs and still log base b, so the base stays the same, but now we have log base b of m plus log base b of n. And the same thing goes with the quotient property, except for this time it's subtraction rather than addition, which is very similar to the exponent properties that we had back a while ago in semester 1. So make sure you have these written down. Pause it if you need to. Alright, so we're going to write these as a single logarithm, so we're going to be condensing the logarithms. So we want to put it into one log base 3 in this case. So our goal is to have just log base 3 of something. So what I'm going to do is I'm going to take each one of these, and because it's addition, as you see, there's no subtraction here, it's all addition, which means when we condense it, it becomes multiplication. So I'm going to have x times y times 5, and I'm going to rewrite it as 5xy. Usually we don't see a 5 trailing at the end. That would look kind of funny. So this would be our final answer here. We're just condensing and expanding, depending on what the problem asks. Here we're asked to write it as a single logarithm, so that means that we are condensing. Alright, for this next one, since it's subtraction, we're going to have a division problem here. So we're going to have log of x divided by 6. And since there's no numbers like log base 2 or log base 3, if there's no number, we know that it's just log base 10. Alright, so log base 10 of x divided by 6. Because it's subtraction, it becomes division when we condense it into one log. Alright, this one gets a little bit more complicated now. So what we have here is log base 8 of 4x times x plus 1. Because we know that when it's addition, as we see right here, to condense it, it has to become a multiplication problem inside the log. And now I can distribute the 4x to both parts. So I'm going to have log base 8 of 4x squared plus 4x. And I'm going to make sure to put this guy here in parentheses so that we know that log base 8 of this whole binomial here. So we want to make sure we're taking the log of all of this, not just the 4x squared. So parentheses are important. Alright, for the next one, you can pause it here and try it on your own and then see how I do it, or watch me go through it right now. So for this one, I have mostly addition. However, then I get subtraction going on right here, so I know there's going to be some division. So basically what I remember to do is, well, if it's going to be log base t, anything that's positive, any log that's positive, whatever we're taking the log of, that goes in the numerator. So this one right here is positive, so the x goes in the numerator. Same with the log base t of y, so the y goes in the numerator. Same with the log base t of z. All of those are positive, so they go in the numerator. The only one that's negative is the one with the m, so that m will go in the denominator, and I have my final answer. We have condensed it down to one logarithm using the product and quotient properties. Alright, now we're going to expand them, so we're going the opposite direction. So for this one, we're going to have, since it's all multiplication between these three numbers, it's 10 times x times y. It's all multiplication, so when we expand it, it's going to be all addition. So we have log of 10 plus log of x plus log of y Well, I know that log of 10, which is basically log base 10 of 10, that's 1, as we learned earlier. So 1 plus log of x plus log of y. Alright, we're going to try one on the next page here instead of doing this next one to save some time. Alright, so let's take a look at this one right here. So here I have, what I like to do is, for the ones that are in the numerator, I think those are all going to be positive. The ones that are in the denominator, I'm subtracting those because I'm dividing by them, and when I expand, it goes from division to subtraction. So I'm going to have log base 6 of 6 plus, because the a is in the numerator, so that means that it's going to be positive, log base 6 of a, and now I'm going to the denominator, so I'm going to do subtraction, minus log base 6 of b, and we're still in the denominator, minus log base 6 of c. Now I'm almost done, but I look over here and I see log base 6 of 6, and that reminds me of the first slide that we went over, which means that that's going to be 1. Then we have plus log base 6 of a minus log base 6 of b minus log base 6 of c. And that's my final answer, completely expanded from what we had before. Any questions? I can't answer those questions. That would be impossible. Alright, so power property of logarithms. Basically what this one states is that we can move an exponent here, like this 5, out to the front of the log. So what we'd have is 5 times log base 6 of 6. And remember, log base 6 of 6 is 1, so we have 5 times 1, which gives us 5. Now it's not always going to work out that way, but we can always move that 5, that exponent, out to the front of the log. And we would be doing that if we want to expand. So we want to get as many logs as possible and as much out of the logs as possible. When we are trying to condense, we're trying to get it all into one log and as much into one log as possible. So let's try one of these here. Let's say we have this 4 here. We're going to pop that guy out front, and we have 4 times the log base 2 of 2. So this one becomes 1, so I have 4 times 1, which equals 4. Alright. So a little bit trickier problems. So for this one I want to condense. That means I want to get everything into one log. What I'm going to do first is deal with my exponents, which would be something like this guy here. I can move up to an exponent, and that's why I deal with it first. Remember our PEMDAS, our order of operations. So what I have is log base 8 of 4 squared plus log base 8 of 4. And that 4 squared becomes 16, so I have log base 8 of 16 plus log base 8 of 4. And I can multiply the 16 and the 4 because I have this addition here. If I want to condense it into one log, I have to multiply because I have addition here because of my product property. So I have log base 8 of 64, and we know that log base 8 of 64, if you think about it and say this is equal to x and put it into the exponential form, 8 to the x equals 64, we know we're going to get 2 for our final answer. This is something that you guys should become familiar with, and just know that log base 8 of 64 is 2. Log base 7 of 49 is 2. Log base 6 of 36 is 2. Those you guys should just know will make your life a lot easier. Alright, over to this one here. Once again, I'm going to move this to my exponent. So I'm going to have log base b of 25 raised to the 1/2, that's an exponent, plus log base b of z to the 4th. Well, 5 to the 1/2 is 5, so I have log base b of 5 plus log base b of z to the 4th. And now I can deal with the addition right here. And I know that that's going to become a product when I put these two together. So I'm going to have log base b of 5 z to the 4th. Alright. Let's keep moving. Well, let's try one of these because we have some subtraction here. So for this one over here, I'm going to do division, so I have log base 2 of 40 over 5. So I get log base 2 of 8. And I know that 2 cubed gives me 8, so my answer would be 3. That was pretty quick. Let's try this one now. I move this 3 up to my exponent. So I have log base 9 of x minus log base 9 of y cubed. And now, because I have the subtraction here, I can make a division when I put it into one log, once I condense it to one log. So I'm going to have log base 9 of x over y cubed. And remember, we can do that because of our quotient property, one of those first couple properties that we learned. Now let's say we're going to expand these. So we're going the opposite direction of what we just did. So if I want to expand, I know that I'm going to have log base 8 of x to the 5th plus log base 8 of y cubed minus, because I'm dividing by z squared, log base 8 of z squared. And now I can just move each one of these exponents to the front. So I'm going to have 5 log base 8 of x plus 3 log base 8 of y minus 2 log base 8 of z. For this next one here, think of this as being written as, this is our final answer over here, think of that as being log base 9 of x y to the 1/2. So you would separate down to into addition and move that 1/2 out front. You'd be done. So once again, when we see the square roots, third roots, or cube roots, or fourth roots, we can rewrite it with an exponent. So let's rewrite this one as log of m n p to the 1/4. What I'm going to do with this one, since there's no more exponents inside the parentheses, I'm just going to put that 1/4 out front. And now I can split it up. We have 1/4 log m plus 1/4 log n plus 1/4 log of p. And there's my final answer. And last but not least, for this one, I'm going to distribute my exponent in because I got a couple different exponents. I got that 3 there. I've got the 4 right here. So I'm going to distribute that in and see what we get. We'll have log base 4 of a to the 6th b squared c to the 8th. And now we can split it all up. So I'm going to have log base 4 of a to the 6th plus log base 4 of b squared plus log base 4 of c to the 8th. And then we can just move all the exponents out in front. And I think you guys can get it from there. And that's it. Bippity boppity boo.